Question 1, negative 3 squared plus negative 2 squared. So it's actually saying here negative 3 times negative 3, which would be positive 9 because negative times negative is positive. And negative times negative again is positive, and 2 2 is 4. So that's 9 plus 4, which is 13. Question 2, what percentage of 40 is 8? So we're expressing 8 as a percentage of 40. We put 8 over 40, then multiply by 100%. Then we simplify. 10 into 40 goes 4 times. 10 into 100, let's go 10 times. Now 4 into self goes once, and 4 into 8 goes twice. And 2 times 10 is 20, so that's 20%. Next, number 3. When 45 is written as a common fraction in its simplest form, the result is. So we're writing 0.45 as a fraction in its simplest form. This is decimal, so it'd be 45 here over 100. Now we want to simplify this, divide by a number that can divide both numerator and denominator. And 5 into 45 goes 9 times, since 9 5 is 45. 5 into 100 goes 20 times, since 5 times 20 is 100. Solution is A. Next, if 235 times 48.7 is 11,444.5, then 2.35 times 4.87 is what? We can do this several ways. We can consider that this quantity here is close to 2, very close to 2, and this quantity here is very close to 5. Think about it. If you have $2.35, that's like $2. If you have $4.87, that's like $5. And 2 5 is 10. And the closest figure to that is A, which is 11.4445. The whole number portion is 11. The whole number portion here is 114, so that's way off. The whole number portion here is 1,000 plus, 11,000 plus. These are off. Now, the other way of doing this is look at the fact that we have 2 decimal places for this quantity, 2dp. For this one, we have 2dp. Add 2dp to 2dp, we get 4dp. So we're looking for the answer with 4 decimal places. And bear in mind, this must be when we multiply the last digits. 7 times 5 get 35. And so we know that the answer ends with 35. So therefore, you can go ahead and use that method. A test was marked out of. A boy scored 60% of the marks on the test. How many marks did he score? Well, 60%. He got 60% of the marks, right? So 60% of 80 is what? 60 out of 100. That means 60%, or 60 per 100. And the off, we change that to times. Well, 10 into 100 is 10. 10 into 60 is 6. 10 into 10 is 1. 10 into 80 is 8. We're left with 6 times 8. 6 times 8 is 48. For question 6, we're told that Dan sold 40 tickets in 5 days. Each day he sold 3 more tickets than the previous day. What is the ratio of the number of tickets sold on day 3 to the number of tickets sold on day 5? So he sold 40 tickets in 5 days. And each day he sold 3 more than the previous day. So we don't know the amount he sold on day 1. So we're going to use X for day 1. So day 1, let's use X to represent the amount he sold. Day 2, he sold 3 more than day 1. So that's going to be X plus 3. We add in 3 to the previous day's amount. The same thing for day 3. It's going to be 3 more than the previous day. Each day he sold 3 more than the previous day. So on day 3, he sold 3 more than day 2. So we add 3 to day 2 to get the amount for day 3, which is X plus 6. We're going to continue the same manner. We have X plus 9. And day 5, it's going to be X plus 12. All right. Now, if we add up the amount he sold each day, we're told we should get what? We should get 40. We can actually write an equation out of, well, it's already an equation, but we can simplify it by adding the X's. We have X plus X plus X plus X plus X. That's going to be 5X. If you add in X 5 times, that's 5X, or 5 times X. We're going to add up the constants. 6 plus 6 plus 9 plus 12, and that's going to give us 30 equals 40. And so we want to simplify that. We can transpose the 30 over, or in other words, we subtract 30 from both sides, so that gives us 5x equals 10. If we subtract 30 from this side and 30 from this side of the equation, you have 5x equals 40 minus 30 is 10. And then we're going to divide both sides by 5, and so that's going to give us x equals to 2. So no X is 2. But remember what they said. They want the ratio of the number of tickets sold on day 3 to the number of tickets sold on day 5. On day 3, we know that number of tickets sold is what? It's right here. That's X plus 6. And on day 5, the number of tickets sold is X plus 12. And then we look at the fact that we know the amount of tickets sold on day 3 now, because we know 2x is actually 2. So that's going to give us 8. And we know the number of tickets sold on day 5. So that's 2 plus the 12. That's what x is, 2. and 2 plus 12 is 14. But we can simplify this further. What quantity can divide 8 and 14? In other words, what's the highest common factor of 8 and 14? That's 2. So 2 goes into 8 4 times, and 2 goes into 14 7 times. So the answer is 4/7. That's the ratio in the lowest form. Number 7, which of the following sets is defined by this set below notation here? X is a member of integers, so looking at all integers, negative and positive whole numbers, including 0. We're told that X is greater than -2. All right, so we know that we'll include -2 because of the dash underneath the inequality symbol. Dash underneath means equal, so we include in -2. And the only option with -2 is obviously D, so that has to be the answer. We can just eliminate these right away. But if we look at this as well too, X is less than or equal to 4. We have to include 4. Again, we can see why D would be the answer in that case. The set of positive integers that is divisible by 6 is an example of what? 6 is the first positive integer that's divisible by 6, right? Because every quantity is divisible by itself. Then all the other multiples of 6, positive multiples of 6, 12, 18, 24, and so forth. And you'll never stop finding those. You keep on adding 6 each time, and you will never stop adding 6. All right, there's no restriction in the instruction. It says a set of positive integers, and that goes on forever. So that's an infinite set. A quick way to look at it is this: that the number of elements in A union B is what? 23, right? Right. But when you add the number of elements in A, which is 14, to the number of elements in B, which is 15, you actually get 29. But that's more than 23. You're told that in the union, we bring in the number of elements in A and B together to get 23. So that means there's an overlapping. That means some of the members in A are also in B. So to find that additional amount, that's in the intersection, you subtract, and that will give you 6. All right, and a more useful formula is that the number of elements in the intersection of A and B can be found by saying the number of elements in A plus the number of elements in B minus the number of elements in, it's a nice formula. Number of elements in A intersect B is number of elements in A plus number of elements in B minus the number of elements in the union of A and B. And so the number of elements in B, A is 14, in B is 15, in the union is 23. And this will make it easy for us because it's going to be 29 minus 23, which is 6. Look at the next question. All right, well, this is not too clear, but I'm going to read it still. Items 10 and 14 refer to the following Venn diagram, which shows the universal set. So we have the universal set here, and we have set T and C, as we can clearly see, though. We can see this is set T, this is set C. That represent the students in a class who play tennis and chess. Okay. So observing the Venn diagram, we know that in set T, every single person who's named in set within the circle of T, they are part of set T. So even these two persons here, Paul and Rima, they are within set C. But because set C is within set T, it means that Paul and Rima are also part of set T. So now let's look at the first question. It says, how many students play both games? Well, again, that would be Paul and Rima. Because Paul and Rima, they're part of what? Set C. And Paul and Rima, they are within the circle of T as well, not just within the circle of C. So they also are part of set T. So Paul and Rima are the two persons that play both games. In other words, they're in the intersection of T and C. So T intersects C, that will include Paul and Rima. So those are the persons who play both games. And the number of elements in that intersection will be equal to 2. Next, how many students play exactly one game? How many persons play exactly one game? Well, those persons who play one game are those persons who are just in the circle of T. Alex plays only tennis. Ali plays only tennis. So does Kayla and Tom. So we have 4 persons there. They play exactly one game. 30 students in Teacher May's class have either dog or cat or none of the two. 16 students have dog. Number of students who have dogs equal 16. Number of persons who have cats. 12 students have cat. So that's, and the remainder have neither a dog or cat. Now we'll look at the option A. Option A is telling us that we have within the circle of D, we have 14 and 2. So that's 16, which is correct because it says here that we have 16 person wound dog. But when we look at the other option, that's off because we're now seeing that within the circle of C, we have 12 and 2. So that's 14 persons owning cats or having a cat. So when we look at this though, this is saying we only have 12. So option A is out. When we look at option B, within the circle of D, we have 16 plus 12 persons. That's 28 persons. All right, within the circle of D. That means 28 person owned a dog. So that's out. We're told it should be 16 only. And for this one, within the circle of D, we have 16 plus 2, that's 18. And again, that's out because it should be 16. So the only option that's left is D. And I'm sure you can see why. At a bank, EC $2 is equivalent to US $1. For every US dollar exchanged, you should be getting EC $2.60. However, it says here that for every US dollar exchange, they're deducting 10 cents as exchange fee. Instead of getting $2.60 for every US dollar you exchange, you're only going to get $2.50 because they're deducting 10 cents. Therefore, US $1,000 is what amount of EC? So what we do, we take the $1,000 and we multiply it by $2.50 instead, rather than the 260. And if you're multiplying 2.50 cents by 1,000, and think about it, this here is a 2, right? 2 times 1,000 is 2,000. And of course, this is 50 cents. This is 50 cents, all right? 50 cents is really a half. A half of 1,000 is 500. So 2 times 1,000 is 2,000. And this is 50 cents is really a half, right? Half of every dollar. So half of 1,000 is 500. So we're looking at 2,500. That's the answer. Another way to do it is just simply move the point. All right? 3 places, since we're multiplying, we move the point 3 places to the right. 1, 2, 3. Point goes here. Put 2 zeros in those basket there. The point goes to the end, and that's 2,500. Let's look at question 14. A dress cost $1,800 is sold at a discount of 10%. The amount of the discount. So discount is what they're looking for, which is 10%. 10% of this quantity, we simply do what? We move the point 1 place to the left, and that's 180. Or we put 10 over 100 times 1,800. So cancel with the zeros there by divided by 10. Divided by 10 again, these two cancel, you're left with 180. Or 1 times 80, 180, which is 180. 7,000 is borrowed at a rate of 5% per annum for 3 years. Simple interest will be what? Well, simple interest, is going to be I equals PRT. That's principal times the rate times time over 100. And so if you look at the principal, which is 7,000, you multiply that by the rate, which is 5, and that's the time taken is 3 years. Cancel off the zeros. That's divided by 100. And we're left with 70 times 5. Now, 70 times 5 is what? 7 5s, that's 35. So that's going to be 350. If you multiply 70 by 5 and then multiply that by 3, what would you get? Okay, so you have 350 times 3, all right? And 3 times 0 is 0. 3 times 5 is 15. 3 times 3 is 9, and 110, that option. Okay, another way you could have done this, which is, if you, looking at making it fast, you find 10% first off, and 10% will be 700. Move the point 1 place to the left. So 10% is 700. So 5% will be half of 700, which is 350. So you're getting 350 per annum, since it's simple interest, and it's the same amount you're getting each year. So year 1 is 350, year 2 is 350, year 3 is 350. So in 3 years, so 3 times 350, and as I mentioned before, that's 1,050. That's another way of doing that. An article bought for $125 was sold for $100. The loss as a percentage of the cost price. So obviously, if you bought something for $125 and you're selling it for $100, then you're going to make a loss of $25. You sold it for less than you bought it for. And the loss as a percentage of the cost price, you put the loss over the cost price and then multiply by 100%. So you're expressing the loss as a percentage of the cost price. So the loss goes on top. Cost price, which is the original price, 125, and you multiply it by 100%. Now, we know that 25 into 100, well, 25, we see this number 125 ends with 25. So we know that we can divide by 25, because 25 can enter itself, and it can also enter 100. So we can use any option for numerator to denominator. Now, how many 25 goes into 125? That's 5. You can check that out. And 25 into 100 goes 4 times. Now, 5 into 5 goes once, and 5 into 25 goes 5 times. And 5 times 4, that's 20. The cash price of a television set is $350. So we have the cash price. And when bought on hire purchase, it includes a deposit of $35, followed by 12 monthly installments of our payments of $30. So you're paying $30 for 12 months. So you're going to have to multiply 30 by 12. All right? $30 each month for 12 months. You're adding 30 12 times. So 30 times 12. And so any payment you make under hire purchase that goes under the hire purchase total, you make a deposit. Because you're using hire purchase, that goes on the hire purchase, including the installments. That's 35 plus, now 3 times 12 is what? 36. So that's 360. Since it's 30 times 12, you put back the 0. And then you're going to add those together to get the hire purchase amount. So 360 plus 35 is what? So we have 360, 35, that's 395, okay? Now, how much is saved by paying cash? So if you buy it by cash, you're paying $350. If you buy it by hire purchase, you're paying $395. So you basically subtract to find out how much you would save. And that makes sense, right? You just have to think about it a little bit. Now, subtract 0 from 5 is 5, 5 from 9 is 4, 3 from 3 is 0, so that's 45. So you save $45. If you're going to take it by hire purchase, you have to pay $45 more than the $350. Okay, I can just do 21 here. 7 times the product of two numbers A and B may be written as what? 7 times the product of two numbers A and B. So the product of A and B, these two numbers A and B, will be A times B. Product means the result from multiplication. Product is the what? Result from multiplication. And you want to multiply this by what? By 7. So that's really 7AB. If the simple interest of $900 at 4% per annum for T years is 108. What is the value of T? So we know that simple interest formula. I tend to use this a lot. 100I equals PRT. So if I want to find I, I'll divide both sides by 100. If I want to find I. So I is equal PRT over 100. But in this case, I don't want to find I. So what would I be looking at? I'm looking at T, finding T. So I need to get rid of the PR. PR is multiplying. They are multiplying T. All right, collectively PR as a quantity is multiplying T. So to get rid of the PR, I need to divide to get rid of it, right? PR is attached to T by multiplication. Remove it, you have to use the reverse, which is division. And you do that to both sides. So T is really 100 times I over the principal times rate. And the principal here, it says simple interest on $900. That's the principal, the amount you invest in or borrowing. And the rate is 4, so that's the R. Okay, that's the R. The rate is 4%. Okay, so I noticed I left the I unchanged. Okay, so I'm going to remove the I and put the actual value for I. So what amount is that? Remember, it's 100 times I. So it says I is actually simple interest. All right, ignore the word simple. So the simple interest on 900 at 4% per annum is 108. So I'm replacing the I with 108. If you look at these quantities, CXC has made it really easy for the students. So for instance, 9, the number 9 can actually enter into 108, right? Why is that? Because 9 times 12 is 108. So we could do that. Let's cancel out the zeros first. I mean, that's always the easiest road to take. They realized 9 can enter itself as well as it can enter 108. All right, but how do we know 9 can enter 108? Let's say you didn't know 9 times 12 is 108. When you add up the digits 1, 0, and 8, 1 plus 0 is 1, plus 8 is 9. That's a multiple of 9, so that 9 can enter it. A little trick there, but it goes 12 times. 24 goes once, into 12 goes 3 times, and so the number of years is 3. Okay, time taken, 3. Let's just do this one over here. 1 over 2x plus 1 over 3x. Well, 1 over 2x plus 1 over 3x, right? Now the LCM of 2x and 3x is 6x. Now to get that LCM, we multiply by 3, so that's give us 6x. And to get this one, we multiply by 2, right? To get 2 times 3x is 6x. So now they have the same denominator. What you do to the bottom, you do to the top. All right, so we multiply the bottom of the first fraction by 3. We do that to the top as well. we get 3. Multiply the top as well by 2. 2 ones, that would be 2. This should be this is a 1 here. Denominator is the same for both fraction. Then we just simply go across with the numerator, adding them. So 3 plus 2 is 5, and so our solution is B. Number 19. At the end of the year, a car is worth 5% less than what it's worth at the beginning of the year. If the car is worth 19,000 in December, that's the end of the year, then its value in January 2021, that's the beginning of the year, same year. All right, so basically they're asking for what? The original value of the car, because they're saying the car is worth 5% less at the end of the year. So what's the worth of the car in percentage? The car was 100% at the beginning of the year. 100%. And what value that was, we don't know. That's what they're asking us to find. At the beginning of the year, that's January. Now, by the end of the year, in December of the same year, the car lost 5% of its value, which is 95. It's worth 95% because 5% came off the original amount. And that amount, which is 95% of in value, is 19,000. That's the worth of the car at the end of the year, 19,000. And the percentage worth is 95% as well. So you want to find the original percentage. Now what you tend to do, because you're trying to find the original, you put the 100% on top, put the 95 below, and you're going to multiply by 19,000. Okay, it's just this quick technique to use actually. Now the percentage will cancel off there, and then you can say, okay, if you look at this, again, CXC is going to give you some nice numbers to work with. 95 and 190. Just think about 190. Ignore the other 2 zeros. If you add 90 plus 90, you get 180, isn't it? And 5 plus 5 is 10. So 10 plus 180 is 190. So you can see that 95 times 2, or added to itself, will give you what? 190. 2 5s 10, 2 9s 18, plus 119. So you can see that 95 goes into 190 twice. So you're left with 100 times 200. Now 2 times 1 is 2, and just add on the 4 zeros. That's 20,000. Okay, so let's go to the next. So we're saying x squared plus 3y over xy. Well, if we square x, you're gonna get the square of 4. That's 4 squared really, plus 3 times the y value of 2 over x times y, which is 4 times 2. 4 squared is 16. 3 2s, that's gonna give us 6 over 4 2s, that's 8. And 16 plus 6 is 22 over 8. Dividing both by 2, because that's the highest common factor between 22 and 8. Divide by 2, you're going to get 11. Divide by 2, you're going to get 4. Convert to a mixed number. 4 into 11, that's going to be 2. That's going to be a remainder of 3 here over 4. In other words, 4 2 is 8 plus 3 is 11. So this is our solution right there. 5 times the quantity, 2x minus 1 is equal to 35. What is x? 5 is multiplying the quantity, 2x minus 1. So we can, since they're multiplying, we can divide to get rid of 5. We'll do that to both sides. And this leaves us with 2x minus 1 equals 7. Then we can transpose the 1 over. So we have 2x equals 7 plus 1. 2x equals 8. Dividing both sides by 2, we get what? X equals 4. Some person might have distributed the 5 and say you get 10x. And then 5 again. 5 times 1, that's going to be 5. Negative 5 in that case. We have 35 there. Transposing the negative 5 over, or adding 5 to both sides, we have 10x equals 40. And then we divide both sides by 10. And that will give us the x equals 4. This side over here, 20. A man's regular pay is $8 per hour, up to 40 hours. All right, in other words, his basic pay, that means without overtime. For 40 hours, he's getting $8 per hour. He'll get what? Cancel off the hours, and 8 times 4, that's 32. So $320. It says overtime is paid, or overtime is paid at twice the payment for the regular time. Overtime rate is going to be twice the regular rate, since it's 2 times the payment. So it's going to be $16 per hour. All right, for every hour work, he's getting $16. If he was paid $480, what was the overtime pay? Well, we know he got $480, right? He got $480. And $320 of that will be the basic pay, the amount he worked for. That does not include overtime, which is going to be $320. And so when we subtract these, find the difference, we get the amount he got paid for working overtime. So that's 480 minus 320, and that gives us 160. So he would have gotten $160 in overtime. Because remember, you know, for his regular rate, he's getting $8 per hour for 40 hours work. So he got 320. So 320 of that is the regular hours work as a payment, $320. But he got $480. He got $480 for pay. That means he got more than the 320. And anything more than the 320 came as a result of working overtime. And so we want to find out how much money he got paid overtime. So we subtract the 320 from 480 to get 160. Now, we know that his overtime rate of pay is $16 per hour. $16 per hour, right? So another way to look at the overtime pay would be what? The overtime rate multiplied by the overtime hours. What's the overtime rate? $16 per hour, correct? And what's the overtime hours? That's what we're trying to find. But we know when we multiply that, we get what? We get $160. That's what I worked out here. So 16 times what will give us 160? Has to be 10. All right, so that's the overtime hours. He worked 10 hours overtime. Think about it. And he's getting $16 for each of those hours. And 16 times 10 will give you 160. All right, so 10 is the answer. Or you could just simply divide 160 by the 16 hours he worked for, and that will also give you the correct solution there of 10. All right, question number 25. We're told that John has X marbles, Max has twice as many as John. So I like to write these down, John and Max. John has X marbles, Max has twice as many, so that's 2 times X. And it says Max gave John 5 of his marbles. So if Max gave John 5 of his marbles, Max now has 2x minus 5 because he reduces the number of marbles by 5. And he gave it to John, so John has 5 more marbles. So John has x plus 5 marbles. So depending on what they're asking you here, because they could have asked you for the amount of marbles Max has now as a result of giving away 5. That would have been the answer. But the answer we're looking for is the amount of marbles that John has now. So that's x plus 5. So the answer is B. All right, John had X originally. He received 5 from Max. That's it. For this one here, we want the correct expression for A star B. That will actually give us these results. When 3 is A and B is 6, as well as when A is 2 and B is 5. Okay. When we're using this one, A star B, we get 12 over here. When we're using this one over here, we get 9. But we should know this expression will work in both cases. All right, so I already worked this out already, and the answer is going to be 2A plus B. I mean, I've seen this in previous questions. But let's see why it works. Okay, so we have 2A. All right, I mean, you could go through all the other options to check it, but because of time, I'm going to just go straight to the one that really works. All right. So let's use the first one. 3 star 6 equals 12. Let's see. 3 star 6 equals 12. Well, let's put 12 over here. So it's saying 2 times the A value, and the A value is what? A value is 3, plus the B value. The B value is 6. Did we really get 12? 2, 3, 6 plus 6, 12. It's correct. We have 2 star 5 equals 2 times the A value of 2, because A value now is what? 2. And the B value now is 5. So that's 2 times, but we're told we should get actually 9, right? 2 star 5, this should equal to 9. But let's see. 2 times the A value of 2 plus B. 2 2 is 4, and 4 plus 5 is 9. So it actually works. So you can see why D is the correct solution. A is equal to, and we've seen that we have this matrix. What is the order? Order means the order of a matrix is basically the number of rows by the number of columns, right? And the number of rows we have, you know, we have a line going horizontally. Rows go horizontally. And so we have 3 rows. That's the number of rows. Number of columns, That's the vertical lines. So we have 4 vertical lines here of numbers. And so that's going to be 3 times 4. All right. Or 3 by 4. So it's a 3 by 4 matrix. All right. Let's go down to the other one here. Item 28. This is matrix P. And they want to calculate the determinant of P. Determinant of a matrix is simply multiplying the quantities in this diagonal. All right. So we're multiplying 8 by 5. So 8 times 5. And we have to subtract. That's the rule. Subtract what? The quantities going this way, that diagonal. So 7 times 6. And then we work that out, and that will give us the determinant of P. Let's see, 8 5s is 40. 7 6 is 42. And of course, 40 minus 42 is going to give us negative 2. So if you have the number line here, all right, and you have 40 here, and you have 0 here. So you got 40. And if you subtract 42, well, let's subtract 40 first. That will give us 0. 40 minus 40 is 0. So you go to the left when you're subtracting, right? And then you have to go, but you're not subtracting 40, you're subtracting 42, so you have to go 2 more over. All right, so you're going 1, 2 more over. That lands you in negative 2. Okay, so you can see why that works, right? Or you can say, okay, the signs are different. And so I subtract, get 2, keep the sign in front of the bigger number there. P being 3, 7. In other words, component x equals 3, y equals 7. Q has components x equals negative 2, y is 5. So when we subtract these two quantities, P minus Q being 7, Q being negative 2, 5 as components, we want to find the result of this difference. So what we do, we take the x component, 3, and subtract the corresponding x component of the other vector. So this is 3 minus negative 2. And should I put the minus and the negative? Okay, and so that will be the x component. Now this will give us a plus. When you remove or subtract negative, you get positive. So 3 plus 2 is 5. Okay, so that would be that would be the x component of the resultant vector. So that's going to be 5. And 7, let's look at the next one now. Let's look at the y component. So it's 7 minus 5. And so we have 7 minus 5. That's the y component we're finding. 7 minus 5. That gives us 2. All right, so our solution is going to be C. All right, items 30 refer to the following diagram of triangle OLM. And we can see triangle OLM here. OLM. R is the midpoint of OL. So if we look at going from O to L, going this direction here, R is the midpoint right here. And they also tell us that T is the midpoint of OM. So if you're going from O to M, the midpoint is T. So that's right here. And we're told that the vector OR is equal to A. In other words, going from O to R. So pay attention to the direction. That direction is actually A. And O to T, in other words, going from O to T here, that's direction is B. All right, let's keep that in mind. Now we're trying to get from what? This is very easy stuff. Very, very easy stuff. Very, very easy. We're going from R to M. So identify where point R is right here. And we're going to go to M. Right? So we're going this direction. The point is, we're going to get from R to M. Now we're not going to go from R to L. We're not going in that direction. I mean, we could, but from L to M, we don't have the vector. But we're told to express RM in terms of A and B. So we pay attention to that. So we're going to go with what we know. So we're trying to get from R to M. So we're going to go from R. Let's see. We're going to go from R to O. That's vector OR. RR, I should say. Not OR, but RO. So O is our transit point. We want to get from R to M. We're going to go from R to O. And then from O, we can go straight down to M. So that's that. Okay, so that's a triangle of vectors. Now R to O. R to O. What's R to O? Now we do not have R to O. What we're given is O to R. So we have to pay attention to that. Now, if you want to go the opposite direction, since it's the same size, same direction, well, opposite direction, is going to be a negative, right? Same size, opposite direction, it will be a negative A. Going from O to R is A, so the reverse of that is negative A. All right, so you have to know that concept. Once you go in the opposite direction, it's going to be a negative. All right, now going from O to T, T is the midpoint, and going from O to T is B. So if you go the same distance, same direction, same and same length, right? If O to T is B, that means T to M is also B. Why is that? T to M is also B because they're the same size and same direction. So we use the same letter to represent that vector. So in other words, O to M is B plus B. If you're going to get from O to M, it's go O to T, which is B, and T to M, which is also B. OT is actually B, and twice that is 2B. So B plus B is 2B. So that's our solution, which we can write the other way around. We can put the positive 2B first and the minus A after, or the negative A after. So that's the solution, 2B minus A. 31. 1 milliliter is 1,000th of a meter. Then 2,500 milliliter is what? So we have 2,500 millimeters, sorry. I want to convert that into meters. All right. Now remember what a meter is. So, I mean, I like to use this method. I just like to say this milli in front is 1,000th. So I'll put 2,500 multiplied by that milli, which is 1,000th. I'll put back the M, which is the meters right here. So when I work this out, this is what I'll get. So we can just cancel 0 with 0 here, 0 with 0 here. And we have 25 remaining, and we're dividing that by 10. Move the point one place to the left, and that's going to be 2.5. I mean, we could have just simply done this with 2,500. Since we're dividing by 1,000, because this 1,000 is underneath the division sign, it means that we're dividing by 1,000. So we're going to go 1, 2, 3. So it's 2.5. Whatever technique you use, that's fine. Okay, so we have a cube. I know what a cube looks like, right? And all these faces are squares. I mean, it's not perfect drawing, but all these faces have the same size. And this is what we call it. These are the faces. And all these faces are the same size. They're congruent. Now, the edge is 10 centimeters. What is the edge, though? That's where two faces meet. So if you look at, this is an edge, this is an edge, this is an edge, and so forth. These are all edges. Each edge, right, is 10 centimeters. So the length times the width times the height, all 10 centimeters. And we know the volume is going to be what? Length times width times height. But they're all the same. So it's 10 times 10 times 10. And that will be 1,000. Okay, I'm sure you can look at that differently. You can say the volume is really L cubed, right? The size of an edge. All right, and so it's going to be 10 cubed, which is 10 times 10 times 10. Give you that amount. Question 33. Oh, let me just work this one over here since we're over there. Now we know the distance around the edge of a circle upon is 88 meters. So distance around, we're talking about 2 pi r. Distance around a circle. You have a circle upon, distance around it is a formula 2 pi r. All right, and we're told that the distance around is 88 actually, so that's 88 equal to pi r. Now they want the radius. So this is the radius. So we'd have to get rid of the 2 pi. Since 2 pi is connected to the radius r by multiplication, we remove it by division. So we remove the 2 pi by division, and r is equal to 88 over 2 pi. Now we're told that at a party, here, let's look at this one, at a party. Okay, at a party, a number of guests were served 15 liters. Let's write that information down. 15 liters of champagne. To convert 15 liters into milliliters, see how much everybody got in milliliters. We're going to multiply that 15 by 1,000. All right? And that will give us in milliliters. So that's 15,000 milliliters. Why multiply by 1,000 though? Because 1 liter is 1,000 milliliter. The other part of the question. So we know everybody got altogether 15,000. Now each glass, they said each guest had 2 glasses of champagne, and each glass held 150 milliliters. So each person, they had 2 glasses of champagne. Each of them held 150 milliliters. So each person got what? 300 milliliters, in other words, of champagne. So what we need to do here to find out the number of guests, right, is to look at the overall amount of champagne served, 15,000 milliliters, divided by the amount of champagne each guest received, which is 300 milliliters, right? And then we can cancel milliliters. Zeros cancel off. And 3 goes into itself once, into 15 5 times. And put back the 0 that we have remaining here. So it's 50. So it's 50 guests. Next, we're told here that we have a trapezium, PQR. And it says the area of the trapezium is 65 centimeters squared. What is the height? Well, a useful formula to know is that the formula for the area of a trapezium, which is half the sum of the parallel sides multiplied by the height. And we're told that the area is actually 65. So we can put this formula equal to 65 since that's the area. And then we could say, okay, one moment, let me just replace that. I'm going to just replace A with 65 since the area is 65, okay? Put back my half. And A, let's let this be A and let this be B. Remember, A and B represent the two sides that are parallel to each other. All right? A trapezium has one pair of parallel sides, and we call them A and B. And so we have 8 plus 18 multiplied by the height. So we're trying to find this height. That's the only thing that we have unchanged. So we're going to work this out. 65 is equal to what? It's going to be a half. And we know 8 plus 18, that's 26 times the height. All right. Let's take this up here. We have 65 equals a half of 26. Okay. Now half of 26 is what? 65 equals half of 26 is 13. So that's 13 times h. Now we want to find h, so we're going to get rid of that 13 by division since it's connected by multiplication. 13 times h. Divide to reduce it, remove it. Now 13 into 65 is actually 5. Okay, if you check it out, 13 times 5. 5 3 is 15. 5 1 is 5 and 1 6. Okay, so the answer is D, 5.0. Put in the 0.0 doesn't matter. Just like when you have money, you can put $5 or you can put 5.00. All right, still $5. Okay, the next, let's go up here. Okay, so now we have this question 37. Compound shape consists of a triangle with height 14 centimeters rest on a square. So this is a square. So all these sides are the same measure. And we can see that the bottom part is a square, top part is a triangle. Now we're told that the area of the triangle is 14 centimeters squared. What is the area of the compound shape? Okay, so let's figure this out together. So we know the area of a triangle because they told us that the area of a triangle is 14 centimeters squared. So you're working what they gave to you. And you can probably put down the formula to figure something out here. Let's see. Area of a triangle is half times the base times the height. All right? And we know the height of this is what? 4 centimeters. The height of this triangle, we're told, is 4 centimeters. This 4 centimeters belong to the height. Okay, they told us that. Let's go back and see. The triangle of height 4 centimeters. Okay, good. Now half times base is actually the area of a triangle. And it's half times the base. And we know the height is what? What's the height? The height is 4. And it gives us the area of the triangle. In this case, we're told it's 14. Now let's rearrange this a little bit. Let's put the base first. All right, base times. Because remember, the order in which you multiply doesn't matter, right? So we put the base first, then put the half times 4, and put about equal 14. I just rearrange the multiplication. Doesn't matter. Half of 4 is 2, right? So this is gonna work out to what? This is gonna work out to 2. Half of 4 is 2. And 2 times b is 2b. So that's 2b equals 14. And dividing both sides by 2, we're going to get b equals 7. So the base of this triangle, in other words, is 7. Remember, it's half times base times height. So the base of this triangle is 7 centimeters. Okay? And if you think about it, put it back in the formula. Half times 7 times 4. You can still find the half of 4, which is 2. And 2 times 7 is 14. Okay? So you could have done that as well. Now, the area of the compound shape. What's the area of the compound shape? Well, we need to know the area of the triangle and the area of the square, so we can find the area of the compound. Compound mean we have two shapes together, right? Or two or more shapes together. So the area of the triangle we know is what? 14 square centimeters. We need now to find the area of the what? We need now to find the area of the square. Okay, so let's find the area of that square. Now, each side of a square has the same measure. If the base is 7, then this other side, the adjacent sides, are also 7. Okay, so we know that's the case. Now, we're not trying to find the perimeter of the square. We're just trying to find the area of the square, which is area equals what? Length squared. Because the length, and it's still the same thing as saying length times width, or base times height. But because the base and the height, or length and width, are the same, we just multiply 7 by 7, and we just see 7 squared, which is 49. All right, any two adjacent sides. Product of any two adjacent sides. Product of any two adjacent sides. 7 times 7. So that's going to be 14 for the area of the triangle and 49 for the area of the square. Add them together. We're going to get what? 9 plus 4 is 13. And 4 plus 2, that's 6. That's 63. So the answer is 37B. Now, question 42. It says here, in a box, there are 8 red, 7 blue, and 6 green marbles. So red marbles, we have 8. Blue marbles, we have 7. And green marbles, we have what? We have 6. One marble is picked up at random. So a marble is picked from the pack or the box itself. And the box contains how many? 8 plus 7 plus 6. So that's total is going to be what? 8 plus 7, that's 15, plus 6, that's 21. A total of 21 marbles. So you're picking from a box of 21 marbles. So the probability of picking neither blue nor green, the probability of picking neither blue nor green. All right? So we need to ask ourselves, how many marbles we have that are neither blue nor green? 8 marbles. 8 marbles are neither blue nor green. It's the same thing as asking what is the probability of picking red, because red is the only set of marbles that we have that are not blue or green. All right, and so the probability of picking neither blue nor green is going to be the probability of picking red, which is going to be 8 out of the total, which is 8 out of 21. The answer is A. Now for 43, we're seeing that we have 720 students in total, right? 720 students who played some popular games. Now, so we're looking at this pie chart, and we want to find out how many students played cricket. If you look at this, we can't tell the angle here. We can't tell what angle this is. We can't tell, all right? There's no way of knowing that just by looking at it quickly, all right? I mean, we could guess, but I don't think that would necessarily help us. All right, so here's what we could do instead. We know that there are 720 students, so we can find out what each of these, but for each game, football and tennis and basketball as well, how many students we have who played those games out of the 720 students. So for football, let me use F for football. We have 90 degrees. The angle given for the pie chart is 90. So this 90 means 90 out of a total of 360, right? So that's 90 degrees out of a total of 360 degrees. Football represents 90 out of 360, 90 out of the total, but in degrees in this case. But now I can find that as a that's going to give me 1/4. So all I'm finding here is 1/4. Now, how to get 1/4, by the way? Somebody might want to know that. If If I cancel off the zeros, 9 goes itself once. How many nines are in 36? 4 nines. Because 4 nines 36. So it's a quarter, and we're looking at a quarter of 720 students. A quarter of 720. I can find this by dividing by 720 by 2 twice. Divided by 2, I get 360. Divided by 2, I get 180. Now if you cancel that, let's just divide 720 by 4. 44 goes once, into 7 goes once, remainder 3. 4 goes into 32 8 times. 4 goes to 0 times, so that's 180. For basketball, it's 30%, right, of the entire pie chart. So it's 30 over 100, 30 of a whole. Since we're dealing with a different unit here, we're not looking at degrees, we're looking at percentage. So 30 over 100, right? Basketball represents 30% of the entire pie chart. So 30 over 100 of the 720. Cancel off the zeros, and that's 3 times 72. What is 3 times 72? Okay, so we can write that out here somewhere. We have 72 times 3. So we have 72 times 3, 326, and 3 7 is 21. So that's going to give us 216. So basketball, we have 216 students. Tennis now is in degree as well, just like football. So that's 36 out of the entire 36 degree out of the whole pie chart, which has 360 degrees. I'm going to multiply that. I want to see what fraction that is of 720. So 36 is going to be into 7 once. 36 goes into 36 once again, and into 0 0. So that's 1/10. Now I can cancel off the zeros. So tennis, we have 72. So we can add up those figures and then subtract it from the entire number of students we have. So for football, we have 180 students. Basketball, we have 216. In tennis, we have 72. When we add these up, 180 plus 216 plus 72, we're going to get 8. It's going to be 16. And it's going to give us 468. So that's 468 for those 3 sports: football, basketball, and tennis. So the remaining amount will be for cricket. So for cricket, it's actually 7. Remember, we have 720 students. And subtract the other total, the others, which will total 468. That will give us the number for cricket. Now 8 from 0 we can't, so we're going to borrow 1. Put a 1 by the 10. 8 from 10 is 2. 6 from 1 we can't, borrow 1. We're going to get 6 here. And put a 1 there now. So 6 from 11, that's going to be 5. Now 4 from 6 is 2. And so for cricket is 252. And that's option C. Alright, so I took my time to explain that. Of course, if you're working that live by yourself, this will be faster. Now, it says we have a two-way table which shows the ways in which 200 students in a group are transported to school on a particular day. Alright, so we have 200 students. As soon as pick at random from the group. So if you're picking from the group, how many students we have in the group? 200. Okay, keep that in mind. What is the probability that a student is a male who traveled to school by taxi on that day? So pick a student at random from the group. So a male who traveled by taxi, right? Male who traveled by taxi. All right? And it's out of 200. So let's see how many. So a male student who traveled by taxi. So that's 50 students. So that's 50 out of 200. Cancel off the zeros. And 5 in itself give you 1. 5 into 20 goes 4 times. That leaves us with 1 over 4. So option A. The point where a linear function crosses the vertical axis is what? So we have the vertical axis, y, and we have the horizontal axis, the x-axis. And if we have a line, right, a linear function in this case, and it crosses the x-axis, we call that the what? The x-intercept. The x-intercept. Where it crosses the vertical line. Vertical is the line going up and down. That's the y-axis. Where where it crosses the vertical axis, we call that the what? Y-intercept. Because it intercepts the y-axis, that is the vertical axis. That's the y-intercept. So the answer is, what we're looking for is y-intercept. Okay, so be careful with that. Pay attention to which axis they're asking you for. Question 46. The equation of a line that crosses the vertical axis at the point 0,5 that has a gradient of 4. So I like to just sketch that, where the vertical axis, the y-axis, the horizontal axis, the x-axis. Okay, now we have a vertical line. We have a line that crosses the vertical axis. So let's look at it. Crosses the vertical axis at 0C. Okay, and we're told that that 0C is really what? Is really the point 0,5. So 0 meaning on the x-axis it's at 0. That's the origin. That's the location of this point right here. And the y value of this point is really 5. Okay, so C is really equal to what? 5. So when we look at the general form, y equal mx plus c, or the slope intercept form, y equal mx plus c, we have the gradient being what? 4. So that's 4x, and c just simply being 5. So the solution is C. Next, we're told, which of the following graphs represent a linear function? A linear function. Now, linear, we're looking for straight lines. So this is out, this is out. These are all curves. And we have option A or B. Obviously, if you're given an equation of a line, typically you're unlikely going to be given this one. All right? The gradient of this line is actually undefined. All right? The straight line here. So, and if you look at it as well too, every single point on this line has the same x value. So what you really have, the x value representing the domain values, and you have the y value representing the range. You'll have this particular value here, let's call it x1, will be mapped to many y values, which is a 1 to many. And a 1 to many relation is not a function. Okay? Now if you do a vertical line test, you'll only cut this graph once. I mean, you can do a vertical line test with this line because it's just one straight line going down like that too. So, but a vertical line test, you can strike many vertical lines. It only crosses the graph at one spot, and so that this is a function. That's 47a. 48. The equation of the axis of symmetry of the function y equal 4x minus x squared is what? Now, we're talking about the line of symmetry, like a human being, right? Let's think about a human being. Where is his line of symmetry? Right? Line of symmetry is that line that will cut the shape in 2 equal halves, and you only cut it along this line, right? So you can see that over this side mirrors over this side. So this is a line of symmetry here, going down vertically. So for the parabola, the line of symmetry is this line that will cut it in equal halves, and that will be right down here. And it makes sense too, because you can clearly see that this half here will be matching this half here. Okay, so this is our line of symmetry. And what is this equation? Well, it doesn't have a y value in it. Well, I mean, points on it have y values, yes, but it actually cuts through which axis? It doesn't cut through both axes. It only cuts through one, and that's the x-axis. So we describe it as x equal the value which it cuts. It cuts through 2, and so that's the equation of the axis symmetry, x equal 2. Let's go down to 49. A line is perpendicular to the line, this line. There's a line that's perpendicular to this one. What is the gradient of the line L? Okay, so a line L is perpendicular to this line. Let's call this line P, and its gradient is what? All right, let's common letter M for gradient. Typically, that's what we use. The gradient is the 3/7. Remember, the general form for equation is y equal mx plus c. So ensure that the equation is in that form first before you can take the gradient. It must be in the form y equal mx plus c, and then you can identify the gradient. That's why I call it the slope form, right? Because you can identify a slope once it's in this form. And this equation given to us is y equals 3/7 x minus 9. And you can clearly see that the m is 3/7. So there's a line now that's perpendicular to this particular line P that I describe as P. So what all it means is that you have two lines and they meet at 90 degrees. One is 3/7. The gradient of one is 3/7. The gradient of the other must be what? Must be the negative reciprocal. So the gradient of this particular line that's perpendicular, right? This is line L, right? The gradient of this particular line must be the negative reciprocal. If this is 3/7, this is going to be 7/3. Reciprocate it, in other words. Turn it upside down. All right, so the numerator becomes denominator. Denominator becomes numerator. But now this gradient is positive, so this one must be negative. It must be the negative reciprocal. If one is positive, the other is negative. If one is negative, the other is positive. And so when you multiply them, you actually get -1. Okay, so the gradient of this perpendicular line is right there looking at us now. All right, as I just explained, it's going to be a -7/3/3. So we're saying that f maps the x values onto the y values, and the y values can be found by cubing x. So here we have the domain, which are the x values. So I'm going to take the first x value to be -2. So I'm going to cube -2. Okay, the x value is -2. I'm taking the value in the domain, right, from the domain set, and I want the range set, right? So so -2 correspond to what range value? We have to cube the x value to get the range value. That's what this is saying to us. So when we cube -2, now the power is odd. It's an odd number of 3. And since the negative value is going to be a negative result. And 2 times 2 times 2, that will give us -8. And the only option that has that is this one. Okay, I don't have to check the others. But in case they gave you other values, so let's say give another range with -8 at the beginning, then you certainly would have to check the others. All right, until you eliminate the others. Okay, so let's do 50. G of x equals 7x minus 3/5, and saying g of -6. All is saying that we have a function called g of x, and this is a function. This portion is a function, 7 times x minus 3/5. And we're inputting, this is our input. And the input is usually the x values. So it's 7 times the input minus 3/5. So our input value, which is the x value, is what? -6. Now working this out, 7 times -6 is -42 minus 3/5. This will be -45/5. That will give us -9. So the answer is going to be A. All right. If you want to know why -42 minus 3, check it. You can use your calculator, check it. But the signs are the same. That's a rule. I don't keep the sign. Okay. Or if you're at -42 on the number line and you subtract, you have to go this direction to get more negative. And 3 units up to the left, that is, it become more negative. So that's -45. We can do 53 at one time. So we have a transformation shown in the diagram here. What type of transformation it is? If you look at it, we can see that this looks like it's mirroring each other, right? The two shapes. This is our object, and this is our image. How do I know that? Because we can see the prime on the vertices. So if you look at this, this is P, this is P prime. This is Q, this is Q prime. This is R prime. It's a reflection. Clear as a reflection. And when with the reflection, we draw a line through the object to the image, the mirror line with the line that connects the object and image will form 90 degrees. You can clearly see that in all the cases, right? Right, they all form 90 degrees with the mirror line. That's the property of reflection. And the object and image are equidistant from the mirror line. I should mention that. All right, so from P to the mirror line, same distance from the mirror line to P prime. And same thing for the other vertices. Okay, so now we want the function that's best describe what we're seeing here in the mapping diagram, or the arrow diagram. So we have the x component called the domain values, the y called the range values. And which one is the answer though? Let's look at the first one, x plus y equals 3. If we look at the x value of 2 and its corresponding value y, we add them according to this one here, x plus y give us 3. Well, when I add 2 plus 5, I don't get 3. So that's out. Y equal x plus 3. Let's see. Y value is equal to x plus 3. So this is my y value here, 5. It's saying I could find this 5 if I add 3 to x. Y equals x plus 3. So let's see. Let's put down 5 where y is, in other words. Let's put 2 where x is and add 3 according to the rule here. Are they equal? Yeah. 5 is equal to 5. Let's try another one. 5. Alright, so if I add 3 to x, I get 5. 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 3 is 11. And 11 plus 3 is 14. So it definitely works. So the answer is B. In which of the following polygon does the sum of measures of the interior angles equal the sum of measures for the exterior angles? Now, the thing to note is that the exterior angles, all the exterior angles of a polygon will add up to 360. So the measure of exterior angles is always 360 degrees for every single polygon. And we have 4 polygons given here. All right, there are many more, of course. So, but which one of these, when you look at the interior angle, you'll get 360. This one, interior angle, add up to 180 degrees, so definitely A is out. Okay? Hexagon, that's a 6-sided shape. And so, you know the sum of interior angles will be what? If you look at a hexagon, it's going to be 4 times 180. And so that's going to be out. Pentagon, that's definitely out as well. Okay, that would be 3 times 180, so that's out. But this one will be 2 times 180, so that's going to be the answer. How did I do that though? But I don't want to go into all that since we don't have the time for that. But I'll look at an example of a quadrilateral here, 4-sided shape that you know of, right? These 2 sides are equal. These 2 sides are equal in measure, in length. We know that these internal angles are what? 90 degrees, right? For a rectangle. When you add them up, how much do you get? 360. 90 times 4, 360. And if you ever look at a square, the internal angles, if you add them up, you get what as well? You get 360 as well. So the internal angle will be 360, and the external angles of the polygon will also be 360 for every polygon. So this is the only one that match the internal and external angles. I don't know why I have an X here, but this is the solution. All right, this is the solution. All right, I could go into detail of that, but maybe another video for that as to how I was actually finding the sum of angles, internal angles there. Now we have a straight line, y equals negative x. And of course, the reason for that is that, let's say we have 7 here, and I go across here, and find this point on the line y equal negative x, and I go down. This will have the same x and y will be the same amount as in 7, but notice it's a negative of x, so that'll be negative 7. All right, so when y is 7, x is negative 7. That's why it's saying here that y equal negative x. Any corresponding value. If this is 4, this will be negative 4. So I hope you understand how we end up with that line. Is because every negative x value corresponds to a positive y value in terms of the amount. Okay, now when we look at this line, we want to rotate it based on what it says here. Rotate it clockwise about the origin, 90 degrees. So what would be the image of y equal of this line, y equal at negative x? So let's rotate this line 90 degrees. Where's 90 degrees? Clockwise, anti-clockwise. Anti-clockwise. So if you have a clock, clockwise is which direction? This direction. Anti-clockwise is this direction. This is anti, and this is clockwise, right? So we want anti-clockwise, we're going to rotate it this direction, about the origin. So keeping it fixed about the origin. Now, if this is 90 degrees, obviously, every quadrant, you're going to have 90-degree angle between, for example, the positive y and the negative x-axis. Every quadrant, you have 90 degrees, right? Forming 360. Vertical and horizontal lines will meet at 90 degrees. So if this is 90 degrees, it implies, and this line here cuts it at actually exactly 45. So this is a 45-degree angle right here. 45 degrees. This is also 45 degrees as well. Together add up to 90. But we want to turn this at 90 degrees. So we're turning it. This is 45 so far. And another 45, meaning that we could cut this 90-degree angle here at 45. And so we look at it, it would have turned 45 and another 45, which is 90 degrees. So we have this line. So this line y equal negative x becomes this line here. And this line here is the line y equal x. Okay, and what this means as well is that if we have a line that go across, meet it here, and go down here, if this point here has a y coordinate of, let's say, 8, then this x coordinate here is positive 8 as well, because y is equal to x. They have the same values. If this is go across here, let's say this is 15, then the x value is also 15. Okay, so the answer is actually the line y equal x. I mean, I went into a little detail with that, but I mean, I don't think that would be too bad. Let's look at 56. We have a translation of triangle ABC onto its image A prime, B prime, C prime. So let's zoom into that a bit. All right, now so we have, and we can identify this is the object triangle, because we're seeing the vertex A here, and this is the image triangle because we can see A prime here. All right, this is B. This one is B prime. If you can't see it, I can just put it there so you can actually see it. That's B prime, and this one is B. This is C prime, and obviously this will be C here. So this is the object, and this one is the image. Now they talk about let's look at the question actually. In the diagram, the translation by which ABC is mapped onto A prime, B prime, C prime is represented by which one of these translation vectors? So if you have a translation of a shape, you notice that the shape and its image have the same orientation. It looks like it's just shifted, but was not turned. Once it's not turned, then it has the same orientation, and you can just simply, if you look at it, it's like we just translate it upwards here. All right, that's the movement. So that's the translation vector. So we're trying to find out what is the translation vector. If you know vectors, you know to find the components of a vector on a coordinate plane, you can just draw a line that connects these, right? And we're going from the object to the image, obviously. It's translating that direction. So what we can do to find the vector is to move from A to A prime. Now, when we're counting the units, we have to make sure we look at the x-axis and see how it's calibrated, right? This is the origin here, and this is 1, this is 2, this is 3, and so forth. So we know that we have 1 unit going across. Let's look at the y-axis. Ensure that the units, we have 1 here, we have 2 here, we have 3 here. Okay, good. So, I mean, they could have put it as 0, 2, 4, 6, and so forth. So we have to double check that. So we're counting. So each block, right, or each box has a length of 1 unit. So going from here to here, that's 1, based on the fact that we have 1 unit between boxes, right? So that's 1. So we're going to go from, let me use a different color here. Oh, let me use red. All right, so we're going to go from, this box has a length of 1 unit, 2 units, 3 units, 4 units, 5 units, but I'm traveling left. So that's the x component. So a translation vector, we have the x component and the y component. All right. So because we're going left, all right, x going right is positive and going left is negative. Y going up is positive, but going down is negative. So I want to get from A to A prime. So I'm looking at how this point A has been translated to A prime. So we're going to go 1, 2, 3, 4, 5 units to the left. Remember, going left for the x is negative, so that's negative 5. Then I'm going to go 1, 2, 3 units up. And y going up is positive, so that's positive 3. So the translation vector is negative 5, 3. Okay, so that's helpful. So describing the shape, we say that it has triangle A prime, no, triangle ABC, sorry, has been translated to triangle A prime, B prime, C prime by the translation vector, negative 5, 3. We missed 38 and so forth, but that's fine. We're going to get back to those. So let's go to question 57. All right, so wasn't sure where those numbers are. Okay, so 57 here. We have 57. In the triangle, angle BAC is 30 degrees and AB is 40 meters. The length of AC. How do we find the length of AC? All right. So let's consider that this will be, if we're looking at if we're looking at this angle here at 30 degrees, because we could also use this angle as well. But let's see which one of them they're basically utilized here to give the correct answer. If you look at 30 degrees, this is our opposite. This is opposite of what? The 30 degree angle. Right? Opposite of 30 degree angle. This side here is the hypotenuse. Remember, the hypotenuse faces what? The 90 degree angle. But we weren't told to find the opposite, right? We were told to find the length of AC. And AC would be the adjacent. In other words, it's next to. This is the side next to 30 degrees. Adjacent means next to. This angle is next to the adjacent side of AC. So adjacent to AC. So we will use cosine in this regard if we want to find AC using the acute angle 30 degrees. In the event that can't work, we'd have to look at this angle instead. All right. I mean, it could work if we were working it by ourselves, but I'm not referring to the options that they gave us. So which ratio are we looking at? We know that we have SO, Ka, right? And TOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Since we're working with adjacent and hypotenuse, that would be cosine. So that would be cosine of the acute angle, 30 degrees. That's a formula. Cosine of the acute angle. And this is in the formula sheet, by the way. Cosine of 30 degrees is equal to the adjacent side. In this case, is AC. Now, the reason I'm using that is because we want to find AC. Over what? Over the hypotenuse, all right, which is this case 40. Now, if I want to find AC, I can cross multiply. So 8C times 1 is AC. And cross multiply here, 40 by 40 times cosine 30. All right, 40 times cosine 30. Do we have 40 cosine 30? No, we don't have 40 cosine 30. And we can't select 40 cosine 60. But the thing to note about this, though, that cosine 30 is the same. What's the angle that's a complement of 30 degrees? 60 degrees. So cosine 30 is the same as sine 60. So the angle that will be correct. So either one of these will give you the same result. 40 cosine 30 is what we work out, and that was correct to find the length of AC, but they did not use that option. We look at the angle in that case that when we add it to 30 give us 90. So we use 60 degrees. Okay? So the answer is going to be A. Now if that's confusing you, just understand what I'm saying here. That, okay, let's say we have let's say we give an angle 50 degrees. 50 degrees plus what is 90 degrees? Would be 40 degrees. All right? And so that means that cosine 50 is the same as sine 40. Put that in your calculator, you realize you get that. Let's check it. Cosine 50 equals 0.642, blah, blah, blah. Sine 40, 0.642, blah, blah, blah. Same thing, right? So that's a key concept. So looking at angles that are complementary angles, right? The sine of one will be the cosine of the other. So angles that are complementary add up to 90 degrees. The sine of one will be the same value as the cosine of the other. Now, of course, in the event that you still don't understand that, I'm going to utilize the time here because I want you all to understand the concept still, assuming that somebody is going to watch this video for doing the exam to do the exam next year. All right. Since we didn't find the 30 degree in the option, the 30 degree angle in the option with the 40 40 cosine 30, then we could use the other angle here, which is complementary of 30, because 30 plus 60 is 90 degrees, plus 90 degrees 180. So let's use this angle instead, angle B. So we still have our hypotenuse given to us, so we're going to use our hypotenuse. So we're not going to use tangent. And AC now is the opposite. It's opposite of the acute angle. We have to find AC. So we have to include AC. But it's opposite of the angle now that we're using. Okay, so we're looking at opposite, in case AC, and then hypotenuse. Opposite the hypotenuse will be sine, so we're not going to use cosine. So it's going to be sine of 60 degrees is equal to opposite. What's the opposite? AC over the hypotenuse. What's the hypotenuse? 40 meters. So to find AC, we multiply these two guys. So AC is equal to 40 sine 60. And you see that it actually works there. Okay. All right. So it's not all the time what they give you. Like in this case, they're going to use, I mean, it's multiple choice. They're going to be as tricky as possible. But still testing in your knowledge. All right. So we have the triangles there in the coordinate plane. And what we can see that this is an enlargement, but by looking at it, once you've done this topic, you can see it's an enlargement, because we can look at the triangle ABC. And we can see now that we have the image of it, triangle A prime, B prime, and C prime. And we have this is called a center of enlargement. We draw a line from the center of enlargement to the corresponding vertices. All right. And what they're asking for though, they're asking for the scale factor of enlargement. They're asking for the scale factor of enlargement. So this is the object. So just like when we have translation, reflection, all of those types of transformation, we have the object, shape, and we have the image. Transform the object to the image. The scale factor of enlargement will be equal to the image length over the object length. Okay, you also put the image on top over the object length. So what is the image length? Let's choose two sides, corresponding sides from the object and image that we can actually measure their lengths. So let's choose just choose this one, the side here, side AC. So I'm going to put A prime C prime over AC. Okay, so you can see the dash means that's the image we're looking at. A prime to C prime will be what? So A prime to C prime, this is A right here, and this is A prime, this is C prime right here. We have 1 unit, 2, 3, 4 units. And the corresponding side for the A prime, C prime in terms of the object is the side AC. So we have 1, 2 units. Divided by 2, 4 by 2, we get 2. So that's the scale factor of enlargement, 2. If you selected this side, for instance, that corresponds to this side, that will be 2 over 1, which is going to be still 2. All right, let's do question 59. A plane is flying in the direction of 45 degrees, changes its course in a clockwise direction to 135. The angle through which the plane turns is, okay. So let's assume that's a starting point. Well, the point along which the plane is traveling at 45 degrees. So this is the north line, and we usually measure from the north line in a clockwise direction, right? And this is going to be 90 degrees. If the plane is moving along in an eastward direction, that's 90 degrees, because we measure from the north line in a clockwise direction, so that'd be 90 degrees. But they're saying that the plane is traveling in 45 degrees, so that's be halfway between here, right? I mean, that doesn't look like halfway, but let's try to make it as, sensible as possible. So the plane is traveling along this road. Okay, so that's 45 degrees right here. I mean, we should write with 3-figure beer and like 0.45, but we just want to work the answer out. All right, so now the plane is traveling along this line. And so let's say that the plane is right, particularly, let's say it's right here. No, and it's going to turn at this point. All right, so we put a north line here as well. Right, So we're going to measure from this north line. And 45 degrees is 135 degrees is what? All right, turn from the north line, clockwise direction, 235. Now this is going to be 90 from the what? From the north line, and 135 will be somewhere here. 135 is exactly between between 90 degrees and 180 degrees from the north line. So it's going to be somewhere right here. Right? So that's going to be 135 degrees. That angle right here is 135 degrees. Let me just take these out. Okay, good. So we understand that. That's 135 degrees right here. Okay, now I remember we said that it was traveling what? At an angle of 45 degrees. Which again, this is 90 going across here. This 45 is going to be somewhere here. So that's 45 degrees here. So what's the angle in which it turns? So it's traveling along this line, but then it turns from this line down to this line. From this line here to this line here. What angle is that? What's the angle of turn is that? Remember the whole thing from the north line is 135. And this portion here is what? That portion here is 45 degrees. So how much more would you need to get 135? So 45 plus what gave us 135? That's the angle of turn. Remember, you're turning from this line to this line. So we simply subtract 135, subtract 45, and you're going to get 90 degrees. 5 is 0, and 4 from 13 is 9. Okay. Again, if you're doing this by yourself, I mean, you probably will do it quicker once you understand the concept. Okay, so we have an angle P formed by two equal sides in an isosceles triangle. So, isosceles triangle, these two sides obviously are the same measurement, and these are base angles. Now, quickly, before I even do anything else, just want to quickly mention this, that this side, if this side is, well, this side is the same length as this side, it means that the angles that face them will also be the same measure. The base angles, in other words, will be the same. And we're told that this is the angle P that's formed by these two sides that are equal. So this side are equal length, and they form what? Angle P, right here, which is x degrees. Okay, so we get that. Now the base angles will be the same, and we're told that these are angle Q and angle R. Now, how do we find the measure of, or the size of any one of these angles, Q or R? Obviously, did that give us the angle for P, so we can find the actual measure. It's an isosceles triangle, not a equilateral triangle. If this were 60, then these other two base angles would be 60, but we do not know what x is. But we can find x in terms of creating a formula. That, for instance, let me show you. If this is an isosceles triangle, and this is, let's say, 70 degrees, what would be these two measures? These two measures would have to be equal, because it's an isosceles. So we take 180 degrees, and we subtract what? We subtract 70 degrees, and that will give us 110 degrees, right? So these two angles would add up to 110, because when you add this angle and this angle of 110 to the 70, you get 180. But they're divided equally, so we have to divide this by 2. So we have to divide the 180, so put it in a nice formula, it's 180 minus 70. Whatever answer we get, which is 110 in this case, we divide by 2. So that's the form. So we will do the same thing. We'll do the same thing with over here. With what we're given, we're going to take the 180, subtract the angle, just like we subtracted the 70, we'll subtract the x, and whatever angle we get, or whatever measure we get, we're going to divide it into two equal parts for angle R and angle Q. And so the answer is C. Okay. Now let's look at those that we would have missed out on. Yes, 38 and 39. On leaving Trinidad, the time on the pilot's watch was 23 hours. When he arrived at his destination in the same time zone, on the next day, his watch showed 3 hours, 3 o'clock. If the average speed of the aircraft for the entire journey was 625, I'm assuming that is actually 625 we have there. Okay, I'm assuming that's the case, 625 kilometers and not 62.5. Then the distance covered by the aircraft was what? Okay, so let's look at this. Distance, looking at this, the formula, speed equals to distance over time, right? And we want to find the distance. So what do? We multiply these guys, right? If you want to put speed over 1, you're going to say distance times 1 is distance. I multiply speed by the time, right? So speed times time. So what's the speed? Speed is 625 kilometers per hour. I'm going to leave out the unit, km/h. And the time taken, okay, so to move from 23 hour on the clock to 3 hour on the clock. Well, you have to get to 24 hour first, right? Because it's a 24-hour clock that we're looking at here. You get a 24 clock, all right? And then you start counting from 1 after that. So this is to get from 23 to 24, that's 1 hour would have passed. And that's like 12 o'clock. And then you go to 3 o'clock. All right, from 12 to 3 o'clock is 3 hours. So that's 1 plus 3, which is 4 hours would have elapsed. So we're looking at 4 times 625. So let's work that out. 625 times 4. 4 5s, that's 20. 4 2s, 8. And 2, that's 10. 4 6s, 24. And 1, 25. And that's going to be 2,500 kilometers. Okay, so this was indeed 625. Ms. Clark arranged the 15 test scores of her students in order of size and select the 8th score for reporting purposes. Which of the following statistical measures did Ms. Clark obtain? Okay, so that looks like the median. All right, you have 15 test scores. All right, and so obviously the 8th will be in the middle. All right, because you have 7 scores over here, 7 scores, and in the middle you have the 8th score, right? And so that's the median. If you want to put 60, if you want to put 15 numbers according to size, you want to put 15 numbers, you'll see the 8th score is it falls in the middle, and that's the median. Item 40 and 41 refer to the following diagram, which shows cumulative frequency curve based on 200 students who took a driving test. Okay, so we can definitely see the top of this ogive. We have what? Top of it, we have 200. And cumulative frequency representing the total number of students here, right? From 1 right up to 200, the top. And these students are arranged according to the marks for the driving test. So, I mean, no child seemed to have received less than 10 marks. Like this child here, number 1, the first child, his mark is 10. The child, well, is it 1 really? Let's check. Okay, this number here, look at how it's calibrated though. Okay, this is 40, so this is actually 20. All right, 20 here, and we have 1, 2, 3, 4, 5. So 20 divided by 5 is 4. So each of these is actually 4. So the 4 students here would have scored 10 marks. This is 8, 12, 16, 20 students. Okay, so 4 students scored 10 marks. All right, so what I did was very useful a while ago, in that we need to know that each of these units, each of these little small boxes, have a length of 4. All right, we're counting in 4s. And 4 students, each of them represent 4 students. On this axis, the x-axis, or horizontal axis, we need to double check as well. From 10 to 20, to 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So each of these represent 1. 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. All right? Just to give you that confidence. All right, now, how many students scored at most 45 marks? So we look at the 45 mark right here, between 40 and 50. So that's 45 marks. I want to find out how many students scored at. What we'll do, we'll go up to this point here, Go right up to this graph. Go right up. Following this line. Hope we can actually see it. Let me see if the highlighter is actually working here. Go up on this line here. All right. Looking at this line right there. All right. So we're looking at this point right here. That's right in between. All right. This mark and this mark right in between them, those two. And we're going to go across to see where that lands us. Right in between to where that lands us. I can imagine this is just tough on a computer to figure this out without having able to draw lines to see where that is. Okay, so right in between here. Now remember, each of these little boxes have a length of 4, right? So since we're between 2 boxes, then we got halfway, that's 2. So in other words, let's say we have this 160 here. Every box is 4 units. My correction. So that's this is going to be 164. This is 168. But we are halfway in between here. So it's 164 plus halfway between 4 is 2. So that's 1. So it's 160 plus 4 plus the 4, right? That's 4. And plus the little half of 4 is 2. So you get 166. So 166 students. This is 166 students right here. So back to the question, how many students scored at most 45 marks? Well, 166 students. Because the 166th student scored 45 marks. So it's at most means no more than 45. It means 45 would be the most. 41, the median mark by the 200 student is the median mark scored by the 200 student is the median mark by the 200 students. So we'll look for the median mark. So we have 200. Median will be found by finding half of that 200, which is the 100th student. So we're looking for the 100th student. And so this is 80. This is 120. In between them will be 100. In fact, if you look at this, between 0 and 40 is 20. So every one of these big boxes, our squares, we have 20, 40, 60, 80, 100. Or we could add 80 to 120 divided by 2. And get the 100th there. So what I'm going to do, I'm going to just use a highlighter just because it's, we need to be able to see that. Go across the 100 students, see where they actually hit right there. And I'm going to go down here. That looks like in between as well, right? Make sure we get the right line. Okay, so if you go down here, it looks like it's right between as well. All right. And each of these boxes is actually 1. So this is 30, this is 35 in the middle here, between 30 and 40. 35, 36, 35, 36, 37. And it looks like between 37 and 38. So 37.5. Right here will be 37.5. So that's going to be the median mark, 37.5. All right. So if it's 37.5, we're looking for 37.5. Let's look for 37.5 in the option. But we're not seeing 37.5. We're seeing 30, 37, 40, and 100. We look for the closest one. Since it's actually an estimate. And so that's going to be the answer, 37. So we have completed all the questions. And I hope that this video was helpful.